let's take a look at this, this question here. So find the product solutions of the second order derivative with respect to x equals to 4 times the first order derivative with respect to y. So let's first assume that, so this is my u equals to x times y. Right, so if you wanted to be very careful, this u is a function of xy, right? So you can write it like this. So like we said, when you take the derivative twice with respect to x, then you get, what is this term? This term is x double prime times y. Okay, so I'm omitting the x and y's. I'm just assuming that you know that the big X only consists with x, big Y only has y. Okay, so that's the first term. And then we have du, so partial u over partial y, the first order term. So this is x times y prime. Okay, so to assemble all of these up, we have x double prime times y equals to 4 times x y prime. So what we can do here is that we can divide the x terms and the y term to make sure that on the left-hand side, we only have x, and on the right-hand side, we only have y. Okay, so if this is the case, let's assume that there is a ratio between them. So let's use another color. So if your left-hand side only has x, right-hand side only have y, so let's think about it. Is there any possibilities that we get a non-constant ratio? So let me ask you this way. So here on the left-hand side, you are only going to get something with x in it, or a polynomial of x. And on the right-hand side, you are only going to get a polynomial of y. So if they are equal to each other, the only possibility is that you get a constant here. It can't be any orders of x, any orders of y, because if you have a polynomial of x, then it can't equal to the polynomial of y, right? You can't equal to the ratios between y prime and y. So the only time that you're gonna get these two equal to each other is that you will have a constant here. So here we're gonna assume that this constant I call lambda is either, there are 3 possibilities. You can either have lambda equals to 0, lambda less than 0, meaning lambda is negative. So when lambda is negative, I can say that lambda, let me just write it like this, lambda is equal to negative of alpha square. So whatever alpha is, right? Alpha is a constant, then alpha square is a positive number. So negative of alpha square is less than 0, or lambda equals to alpha square that's bigger than 0. So only 3 different possibilities. Okay. All right, so now let's continue with this. So here we have different types of, well, actually before this, let me add one more sentence. So once we have this, we should have 2 different ODEs. Okay, so what you're gonna have is this 2, right? So you have 2 different ODEs. The first equation, it only has x as its independent variable, and the second equation only has y as its independent variable. Okay, so and they are both affiliated with lambda, this constant that we assumed. Okay, so now to solve 2 ODEs is much similar to than to solve 1 PDE. So let's continue with this. So this is our new question now. Okay, case 1, when we have lambda is equal to 0, right? Lambda equals to 0, then you plug into the 2 ODEs. So this gives us x double prime equals to 0 and y prime equals to 0. So when you integrate this, right, so you can solve for each equation. So integrated, you get x equals to C1 plus C2x. So C1 and C2 are both constants, and y just equal to C3, right? So you do 1 time of integration on y and then 2 times integration on x. So this is what you get. And you remember, we assume that u equals to x times y. So it will be C1 plus C2x times C3. And if you want to be very efficient with the naming, so you can say that this is just A1, which one constant, plus another constant times x, right? So you combine C2 and C3 and call that just one single constant. And you combine C1 and C3, that is your A1. Okay, so easy enough for the first case. So now let's move on to another case. So let's see for the second case where you have x equals to negative alpha squared, meaning that lambda is a negative number. So we again plug into the two ODEs. X double prime equals to negative. So here we directly changed the lambda with negative alpha square. I think this is what it says, or maybe lambda x. Yeah, this should be plus when you move it here. Well, okay, so I think there is a typo here. We can just assume that lambda is positive alpha in this, positive alpha square in this case. So I think this is, so then these can be yeah, I think it should be plus, right? So this is the third case in my writing, in my order. Okay, so lambda equals to plus alpha square. So when you plug into this, you get x double prime minus 4 alpha square x equals to 0. And then when you plug into this, you get y prime minus alpha square times y equals to 0. Okay, so here you can use some calculators to help you to integrate this. So x is a very ugly function here. You have cosh and sinh, and y is also this. Y looks actually a little better. This is just an exponential function, and then you can combine these together by multiplying them, and also to categorize all these constants and make sure that you have minimum amount of constants when you're naming this. Okay, so your u is also consists of 2 parts. These 2 parts come from x because your x has 2 parts, right? Just like before, your x has 2 parts and your y just has this 1 part, and you combine these together, you get the solution here. Okay, so u is this a2 e to the alpha square y cosh 2 alpha x plus b2 e to the alpha square y sinh 2 alpha x. So here, I think you might need some help in figuring out this. Feel free to use any types of your calculators to help you do this. Okay, so moving on, we have a third case, right? So when actually in this case, it should be negative, right? So in this case, second case here. So if lambda is negative, then you plug into this and you will have a x double prime plus 4 times alpha square x, and then y prime plus alpha square y equals to 0. So again here, this is, you can use any one of your calculator. You can use also MATLAB to help you to solve this. So you get cosine and sine, and y, this is pretty much the same. You just have a negative sign on the exponential, and you combine these together, you get a3, and in this case, b3. Yeah, this book has a lot of typos. Yeah, so this should be B3 corresponding to this, okay? All right, so those are your 3 cases. I think the most important thing for you to remember is that we have this part. You assume that your solution is a product of purely a function of x and purely a function of y. And you observe that in your ODE, in your PDE, you only have either the second order derivative with respect to x or second order derivative with respect to y, or the linear terms, not the mixed terms, meaning that you have partial u square over partial x times partial y. So once you have these, you just say that it's not possible to separate the variables. Therefore, you can't solve it using the separation of variable methods.